So this is kind of more of a story, but there is a bit of code in as well because we're at a conference. So I kind of want to give you a little bit of the background about what I'm going to talk about. So I work at the BBC. I've been there since 2009, so I've been there for quite a while. Back in the day, I was a Java programmer. So I was employed as a Java programmer. But then quite quickly we moved into Ruby on Rails, and that was most of our infrastructure, or most of our code was written on Ruby on Rails, and it was hosted in our own environment, in our own data centers, which we still have, but we use less. Then we moved into a platform called Forge, which was principally PHP and Java, Java for the back end, PHP for front end. It was mostly Spring Java as well. And that again was hosted internally. And then we moved into to the cloud where we are today. So that's kind of where I'm going to speak about. So my time at the BBC, this is me on Later with Jules Holland with Georgia Moroder. Well, that's me there. And again, on the One Show with Kylie Minogue and Peter Jackson. That's me there. And on the BBC comedy series, W1A. And that's me in the background. That was my half a second on screen. So there you go. So I've been in the background of the BBC for quite a while. But now I actually work in the site reliability engineering team as part of digital distribution. And that's the division that handles all of the audio and video, the kind of shuffling around, the transcoding, and the management of that. So now I'm in a team in the background of the department that works in the background of the BBC. So you can see the theme. But every week we deal with around about 1,000 hours of catch-up content, 3 to 4 terabytes of live audio and video, and 13 million stream play events. And these are the events that come from Sounds and iPlayer, things like that. We also have a number of live events through the year, including Wimbledon and Glastonbury. This was Glastonbury 2022 during Billie Eilish's set. But these events draw massive numbers. So this year alone was quite a record-breaking year. Over the weekend, the Glastonbury weekend, we received 22.9 million live requests for the live streams and 38.1 million requests that was including the on-demand content, which are single tracks and also full sets of the artists. So I also work with around 600 other software engineers across the BBC. That's not them. But some of them are here today. You might see them somewhere. So the 600 of us look after around about 17,000 repositories in GitHub. We have 4,000 plus virtualized deployments, so stuff running on virtual machines in the cloud. We have 2,000 plus lambda deployments at the moment. And we have 1,000 plus separate projects deploying to over 600 individual AWS accounts. So you're asking, what is the solution for the BBC? Well, spoiler, there isn't one. Well, I should say there isn't one, because actually every team has to look after their own tools, or at least historically this is the way it's been. So if you have some stuff to deliver, you need to build a system that was going to deliver it into production. And okay, there's some common functionality or kind of common tools. But even those standard tools are, when they're used in a different environment, they actually end up being kind of changed slightly. So really every team ends up with completely different stuff, even though they're kind of based on the same tools. And so these become what you would call local solutions. But the problem is with these local solutions is they kind of trap people into teams. So there's quite a lot of overhead at learning how a team would deploy into production, how to use all the tooling, how to get stuff into GitHub, what process to use. And it makes it really hard to move around the organization, either to help teams, just for a feature, or to actually move into a new team. So it kind of sticks people into teams, because sometimes it actually takes days or weeks to get up to speed to deliver a new feature into production. So that was one of the learnings that I'll introduce to you, that companies are often hard to communicate across, so things get reinvented over and over. I think we probably have a sort of big situation like this because there's 600 engineers, but I think every organization has this. So we did a little bit of research on this journey to work out what people were actually using. And so across our division, we found that people were using around about over 169 self-managed Jenkins instances. And these are Jenkins instances based on a standard piece of tooling. We call it Cloud Jenkins. But still, you need to manage it yourself. You need to do the work yourself. And we were finding, or the research showed, that up to half a day a week per team was spent managing tooling. And that's a massive amount of time. I mean, if they were just free to do their own features, then surely they would be happier. But we know that most organizations struggle with this. It's not an uncommon problem because we deal with complexity. We deal with complex problems, and getting stuff into production is a complex problem. But we also have lots of stuff. We have legacy stuff, or kind of older software. We have new features that we want to re-implement. We've got new technology, and all of this is competing with our attention. And so tooling is something that we could get rid of, that responsibility for a team. So let's build a standard tool that does it all. Well, I think this is the second XKCD of the conference, but this is, I've used this before as well, that when you kind of think, right, I'm going to build a new standard, so there are 14 competing standards, we'll create a universal standard, and then you have 15 competing standards. So this was another one of our learnings, that introducing a new system, a new approach, adds complexity. And the only way of reducing complexity is by removing that old system that you already had. So we're starting to look at tools now, but we're kind of conscious as well that tools actually, if you just implement tools to do something, that actually becomes the process. That becomes how you interact with well, that's your interface, if you like. So instead of using tools, we, being the SRE team, the Site Reliability Engineering team, we want to focus on principles or practices rather than tools. And one of the principles is release engineering. So these are kind of underlying or kind of headline features that we want out of our build system. So we want the build system to be self-service. We want the teams to be able to do whatever they want to do without having to come and ask somebody else. We want these features to be high velocity. We want to accelerate that route into production. We want hermetic builds and builds that don't change during the or down the chain. So if you test something, you know that's being deployed, not something that's been rebuilt to deploy. We also have policies and procedures we might want to apply. And then this continuous build and deployment, which is actually, this is the tooling that I'm talking about today. So our team have realized quite a long time ago that we can't just go around and say, this is the way you're doing it, just get on with it. We're not gatekeepers, we're facilitators and accelerators of the other team, and that's very much how we focus ourselves. And we actively go out to find ways to include people, even though it makes it sometimes slightly harder for us, but we need to reach out and we need to speak to people. So that's a lot of preamble, but how does Go help with this? So when we started the project to reimagine how we were going to get features or software into production, we looked at a load of different options. We asked teams what they wanted, and we compiled a list of requirements. And some teams needed to deploy on-prem, some in the cloud, some building apps for mobile devices, etc. So we tried initially to build a system that achieved everything that everybody needed, and it ended up being even more complex and actually really hard to manage and hard to explain. So we realized that that's not the approach. It's not the approach to build everything. So I will say that this is a new project I'm talking about today. So this is a new experience, reasonably new experience. This has been the last few years of our kind of journey. So yeah, this is the start of this new project that we're building. As I mentioned, we use AWS, and we actually heavily use AWS. The majority of our deployments are to this cloud environment, but we also do use GCP and Azure and things. But if we were building tooling to deploy to every environment, it makes it really complex. So instead of trying to build tooling that's abstract and it works with anything, we decided to lean in to the tooling that the cloud provider gives us. Because we don't want to solve every problem. We just want to do one thing, or maybe some things well. But we always need to keep our eye on the big problems. We don't want to forget that actually we've got some kind of quite complex problems that we need to solve. So how do you build tooling that does everything you need? Well, I mentioned earlier on that we were kind of focused on processes and not on tooling. So that's what we do. We don't just build tooling, we model these processes. So we kind of looked at what AWS provides us, and we found that Code Pipeline is a technology that actually was quite a good fit for us. Pipeline systems, they're available in most cloud environments. So these technologies, all these features are probably in any cloud provider that you would choose to use. But this is AWS, and this is kind of how they provide their tooling. So we decided that our system needs to set up some pipelines to do this delivery. One thing that we wanted to, well, we definitely were sure on, that the pipelines needed to be totally configurable by the people using them. And they need to have some sort of configuration which lives with the code. We don't want to have a tool over there that's doing all the stuff and then some code here, which nobody understands how it's deployed. So we wanted some sort of definition for a pipeline to live with the code. And so we came up with this format, roughly this format, which is what we call a pipeline definition file. And it's really just a way of describing the type of work that you want to achieve. And there's normally some workflow stages here, or some pipeline stages. So here's just a kind of classic example of a build, test, publish, and deploy of a system that actually takes a change. It then runs some tests, it pushes it into some sort of repository, and then deploys it into an environment. The reason why we're kind of focusing in this way is because we know that tools are temporary, whereas ideas are forever. Well, they're a little bit longer than ideas, than tools anyway. But we want our approach to be future-proof, and we also maybe want to apply some similar principles in another cloud provider as well. So because we're using AWS, we're leaning into the tooling that they provide us, and we considered that the best way of doing this is using the Cloud Development Kit. AWS are putting a bunch of research or a bunch of effort into this now, so it seems like quite a good approach. The tooling itself is written in Node, and we did consider using that, but it, of course, comes with a lot of issues with dependencies. When you're distributing a tool around, you need to make sure that everyone has all of these dependencies. The reason why we were thinking that is because actually back at the time, there was only TypeScript, JavaScript, Python, Java, and C#, and so there was no Go. So to do this kind of deployment or this distribution of the system, we decided to use Docker. So we're creating a container image with all the dependencies, all the stuff in, and this is actually the Docker file from back in the time. But not so long after, actually, the Go language bindings for the AWS CDK were released. So we started looking into these. They were quite an early version, but actually they were really quite stable, we found, and they were fully featured. So we rewrote the code for the stuff that we had at the moment. It took a day to rewrite it in Go. And okay, we'd kind of done that problem solving. We'd worked out actually how to do things. So it was kind of port, really, not a rewrite. But then, yeah, we had our component rewritten in Go. We found that there's really good documentation as well. The CDK documentation is pretty good. But also we found that delving into the code was really useful as well. And I'm not sure, different people maybe approach things in different ways. But I found actually going into the code and the first principle to be really useful, because then I can, work out what code I want to use. Some of the language bindings, I'll say, if you use it, some of the language bindings are a little bit odd looking because they're language bindings for another piece of technology, some other language. So they have like a flavor, like an accent of the other language. So some of them can look a bit strange, but they work really well. They're stable for what we wanted. So that was a win for us. Initially, we were using Docker, but it actually introduced a lot of complexity for the teams that we didn't anticipate. And we were just saying, yeah, just pull the image and run that. And teams it wasn't really fitting in with their workflows. So building these binaries without needing dependencies was a big win for us. What we already know, being site reliability engineering, is that Go is really good for automation. And I think sometimes people think we use Go for these kind of really big projects with lots of processing and stuff. But actually the distribution mechanisms for Go are really great. Being able to build a binary and cross-compile a binary is really powerful. And having that kind of statically typed code that doesn't change, I can't tell you how many times we've debugged issues with Python scripts or something running on a remote environment that's got completely different dependencies. Sometimes subtly different dependencies at runtime as well. So Go really fits well. Because we want to explain to people why we're making these decisions. We capture everything into an architectural decision record. There's a lot of text there, but the important thing is that it's been accepted. But yeah, okay, well, let's have a look at the tool itself. So this is kind of the entry point for the CDK tool, the development kit tool. And there are a bunch of keywords that this CDK tool uses. This one obviously is deploy. And then we're passing into the context some sort of or pipeline definition file. And these are specific to the pipeline you want to create. The CDK tool and your own code is actually wired together with a file, a cdk.json file, which is kind of like a manifest. And it binds together whatever code that you have and the tool. But you might notice the top line of that is a little bit risky because it's doing a go mod download and go run main go every time. So every time you run cdk deploy, it'll run those commands. And okay, there's caching. I don't know if you saw Daniel's talk earlier on. So the first thing you might want to do is change that to a binary and actually build the binary so you know that's not going to change. So a little bit of code. Finally, some code. So this is what the main function looks like to create a stack for our pipeline. There's some code removed from here just to make it a little bit easier to read. But essentially, all we're doing is creating a new pipeline stack, and we're adding stuff to it. And this is all the kind of automation tasks that we want to encapsulate and pass on, to be able to replay with different teams. So the new pipeline stack essentially creates a bunch of properties. It creates a new stack, and then it creates a pipeline. So this is kind of that highlighted. And it's quite straightforward code. Then you would start to add stages to your pipeline. And these stages were defined, if you remember, in the pipeline definition file. So our code would read the pipeline definition file and then add these stages. The difference, or the kind of out-of-the-box one, is the source stage, because that's always there. And that's another decision we made, that we mostly use GitHub. We do use VCS a little bit as well. I think there's, Subversion, I should say. So I think there might be a bit of CVS, but I think that's probably in a hidden dark corner under New Broadcasting House. But we use GitHub mostly. So this is just adding a stage that does the source pull, if you like. Some configuration for the connection. When we're creating a connection to the GitHub, to our GitHub account, we actually create a connection within the AWS account, and that's connected to our organization, so you can pull all of the organization's repos. But here it's just a little bit of configuration to tie together the pipeline definition file and the actual code itself. So if you remember, this is kind of roughly what the default pipeline looked like. And this is what it might be if you had those kind of optional values in, so you could specify what repository and everything you want to pull. So it also has quite good testing functionality. So we can actually do some testing to make sure that the correct assets are being created. Although we are careful to test exactly what we want to. We make sure that we're testing the things that we're creating or intentionally creating, and not just stuff that's a side effect. So it could be, you could get into a situation where you're testing everything and you're just testing a particular implementation. So we're kind of careful about what we test there, just the things that are useful. So what we're trying to do with all of this is trying to add value to the teams without adding complexity. We're trying to make their experience as simple as possible. And then we set about improving it. We looked at the pipeline definition file and realized that we actually want to use different types of containers to do the build stages. So to explain, each of these workflow stages is built inside a container, using code build on AWS. So this is kind of using a default one. But we have lots of different types of default now. So we have ones for different environments, and we have different programming languages. The reason why we've got these standard images are because we have quite a bit of specific tooling that needs to do some of the internal stuff, using certificates and things like that. So we added to the pipeline definition file the ability to specify a default build image, so you can customize it or change it yourself. And that's used for each stage. But then we wanted to amend this as well to be able to specify one for a particular stage, because this kind of speaks a little bit more to the teams that are using, using more specific and more complex builds, and they can encapsulate those in container images. So each stage, you can define the build image as an override, or you can just use the default image. So that kind of leads maybe into another learning that we have learned hard lessons with over time. Sometimes it's called dogfooding, but if teams are going to be depending on your stuff, then you should too. So if there's any pain to be felt with any of this, then you should feel that pain, and that kind of encourages you to fix it. But we actually build our delivery system with our delivery system now, which is a bit like typing Google into Google, I think. I don't know, I'm not sure. But then as soon as we started to use it, we realized that we needed to handle pull requests as well, GitHub pull requests. So previously, this process worked really well if you just commit straight into your main branch. But actually, maybe you've got some QA stages that you need to raise a pull request, and then you need to do something. And this encapsulates that workflow around that, so you can define what steps you want. So, as I mentioned, we are not gatekeepers, we're accelerators. So one of the things we learned over the time as well is that we need to work with people. We need to go and speak to them and include their ideas in the work that we're doing. So we did that quite a lot, and we started to add value. We started talking to senior management, which was really important as well. And being SRE, we love visibility. So we wanted to surface all of the stuff from across the organization onto a global dashboard, which our bosses will really love. They'll have it on their home pages, I'm sure. So we used some Go lambdas for this. And Go and lambdas fit really, really well together because they can be deployed as very small units. We actually do have quite a few Java lambdas, and I can tell you that they're massive. And we've run out of space on numerous AWS accounts because of that. So Go is a really good fit. So just another bit of code. I thought this was kind of quite an interesting thing, and it's just kind of how we test some of our lambdas. So traditionally, we would have a lambda entry point in this main function, and that starts the lambda, and it passes in a request handler. And the request handler looks something like that. You're passing in some context and an event, and then you do stuff, and then you return something. That's great, but the problem is it's quite hard to test because there could be side effects of that request handler, and it's really hard to test if you've got dependencies on external components. So we decided to put together, it's a reasonably standard approach, but using dependency injection. We created this dependencies bundle, and we decide what the Lambda needs to do. In this case, it's sending SQS messages, and then we include an interface for that. The handler request, the request handler, instead of just being a function, it becomes a pointer receiver of that dependencies bundle. And then we kind of lazy load some stuff that we need in production. So if this is executed and it doesn't have it, it'll lazy load it, otherwise it'll cache. And actually we found the performance is pretty good. So then later on, maybe for this SQS client, you need to send a message. So you can use the dependency bundled client to do that. And this is how we start up our Lambda now. So we, instead of passing in handle request, we are creating the dependencies and we're passing in the dependencies version. And it makes it easy for us to test as well. We can mock a client. We use the interface for the SQS type or the API. And we can put some other bits in there as well for our tests. And one of them is this result string. And so that, if you remember what the dependencies look like, it looks quite like the dependencies bundle, but it has this extra result string, which allows us to capture a value during testing. And so we can also implement a send message function, which usually would live in the SQS implementation, but instead we can create our own one, which just captures the message we're passing in. So all of our code does a bunch of stuff, and then it sends a message, and we're making sure the right thing is going out. So we can test it like that. We can create a new mock client. We can create our dependencies with this mock service in. Then we can call handle request directly, and then we can make sure that it's not failed, and then check to make sure that the result that's coming out, the mock service.result, we're grabbing that field and marshalling it, and then just making sure it's okay. So Go testing actually has helped us make a better product overall. I know lots of languages have testing, so it's not unique to Go, but it's Go testing is great. And also, with this extra infrastructure, we can surface our metrics in Grafana. So the code that I was showing you actually comes from some of that infrastructure that intercepts messages, and it sends it through different accounts and then into InfluxDB, and then it's surfaced in Grafana. And I can't show you any of the dashboards, so hence the nice logo. But that means that we can surface all of this kind of story that we're telling. So it means that people can look at a dashboard and see how many builds are happening, when they're happening, how many have failed, and I think that's a really compelling story to be able to tell about your organization. So the thing that we realize is that we don't need to build everything straight away. We need to just get something out there and then brace the feedback. So I do have a little demo. It's a bit of a weird one, and I don't know whether it's going to work, but it might do. Yeah, I think that's okay. So there's some bits that might be a little bit small, but essentially that is a pipeline definition, and this is a project that we're going to deploy. This is just a no-op kind of project, and it has just some echoes, some printlins in there that just make sure that something is running. So this is a screen recording. Obviously, I've shortened some scenes, I should say that. So if we look at an AWS account, we don't have a pipeline in there at all. So we're going to use the pipeline definition, and we're going to deploy a new pipeline. So again, this takes a little bit of time, but actually it is shortened, so you'd be glad to know. So what we're looking at is the stuff that's under the hood. We're looking at things that are happening, behind the scenes, and I'll get to some improvements that we're making nearer the end. So we're nearly there, and we should be able to see that we now have a pipeline which is in progress. And then it's built. So yeah, as I say, that was a really quick demo of the system working. So what we found out by doing this is Go is really great. I mean, I've hammered this point a little bit hard, but Go is really great for automation, for DevOps, for Cloud Eng, for SRE, and that's a kind of powerful place to be, I think. So one of the final learnings I'll leave you with is that, not the final, but this penultimate, but the thing that we found was really important is that senior management need to understand why we're doing this. So it's all very well building tooling, but actually what we did is we went and spoke to senior management and explained to them why this is important and why it's a problem that we should be spending money on. Every company doesn't want to waste money, and we're doubly so because we have public money and we can't waste any. So we're really keen on making sure that there's real value of this, but senior management understanding why you're doing it is a really powerful thing. And as I keep on mentioning, Go is a really good way, or Go is automation, I should say, is a really good way of introducing Go into your organization. Rewriting your headline project in Go is a bit of a tough ask to ask your management to do, but some automation around that, it's quite possible. Maybe some integration tests, maybe a bit of deployment, and that's a really good way. If your organization doesn't use so much Go, it's a really good way of getting that in. But the thing that we keep on coming back to in the team that we work in is that the real problem we're solving is not a technical problem. It's a problem about people. It's not a problem of people, but a problem that people experience. So the future of this, we are working at the moment making this as a service. So we're constantly talk about developer experience, and it's kind of user experience, but slightly rebadged. But it is actually a user experience. So we want a developer's experience to be really nice as well. We don't want to provide some complex tooling and just say, there you go, get on with it. We want to globally update pipelines that are running across the organization. And the real power, and this is something we're working on now, the real power is rather than just having engineers pushing their own pipelines, If, for example, at some point we needed to add an extra QA stage into the pipeline, we could push that into pipelines without them having to do that work. So that needs a little bit of thinking, I guess. So all of the learnings that I've talked about today, I've put on that website. And that's all I have. Thank you.